Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at applications of quadratics. So much like when we are solving worded problems using linear equations, we define a variable. That means we let x be whatever we're trying to find. Then we form an equation, then we solve. Let's start with this example. Sum of two consecutive square numbers is 145. Calculate the two numbers. So what I'm going to do is I'm going to let the two square numbers be x squared. So that will be the smaller one. And then consecutive means one after the other. The next square number will be x plus 1 squared. So if I let these two be the numbers, I've defined the variable. So now I'm going to go to step 2 and form an equation. So the sum of the squares, sum means add, equals 145. So I have this equation to solve here. So what I'm going to do is expand the bracket. So x plus 1 all squared becomes x squared plus 2x plus 1, and that equals 145. So remember, to solve a quadratic equation, whichever method you're using, it requires you to have one side equal to 0. So I'm going to collect the like terms, x squared plus x squared, and I'm going to subtract from both sides 145. That will make sure that one side is equal to 0. So of course 1 minus 145 gives us negative 144. All right, how do I solve this? Well, note each of these terms has a common factor. The common factor is 2. So I'll take that outside. I get x squared plus x minus 72 equals 0. So solving this equation, we can factorize just what's in the brackets. Two numbers that multiply to negative 72 and add to 1, we get positive 9 and negative 8. So using the null factor law, either the first bracket equals 0 or the second bracket equals 0. These are the two options for x. So if x is negative 9, then x squared is 81, and x plus 1 squared, that'll be negative 8 squared, which is 64. If x equals 8, x squared is 8 squared, 64. This one will be 9 squared, 81. In either case, the two square numbers are 81 and 64. They are consecutive because this is 8 squared and 9 squared, and their sum is 145. All right, we're done. Let's look at another example. So here we're going to find the value of x using Pythagoras' theorem. So you might think to yourself, well, what does this have to do with quadratics? Well, Pythagoras' theorem says shorter side squared plus shorter side squared equals longer side squared. So if we use Pythagoras' theorem, we get precisely that. And that will turn into a quadratic. So we have shorter side squared plus shorter side squared equals longer side squared. All right, let's now expand the bracket. So this first perfect square, so x squared minus 64x plus 1024. Now we're going to expand the next set of brackets. So that will be x squared minus 2x plus 1. And that equals x squared. All right, let's collect like terms here to make life easier for ourselves. So x squared and x squared is just 2x squared. Then we have negative 64x minus 2x, so negative 66x. And 1024 plus 1 gives us 1025. Now, when solving quadratic equations, one side must be equal to 0. So I'm going to subtract x squared from both sides of the equation so they cancel out and one side is equal to 0. I thus have x squared minus 66x plus 1025 is equal to 0. So the two numbers that multiply to this and add to this, it turns out, will be negative 41 and negative 25. So there are our options here. So two solutions. If the first bracket equals 0, x is 41. Second bracket equals 0, x is 25. Now just have a think about whether these solutions are possible. 25 isn't possible because that would mean this side is negative 7, a negative. So we'll cross that out. Our solution must be 41. Turns out the side lengths are 9, 40, and 41. All right, let's now look at one more example. calculate the dimensions of a rectangle whose area is 128 centimeters squared, perimeter is 48. So we're going to start by letting x equal one of the things we're trying to find. Now here we're asked to calculate the dimensions. We're asked to find the length and the width. So we're just going to let x be one of those. Length or width, either way, doesn't matter. So if we let x equal the width, what will be the length? Well, we have to use the same letter, x. We can't introduce a new variable like y. We don't really know how to solve quadratics that have two different pronumerals. So how can I write the length in terms of the width? Well, if we have a rectangle and it's 48 all the way around, that's what perimeter means, then the length plus the width will add to exactly half that. Length plus width equals 24. So that, of course, means the length is going to be 24 minus the width. So if the width is x, the length must be 24 minus x. So I have to find both quantities using the same pronumeral. So we're now told the area is 128, but the area is width and length multiplied together. So width times length must give us 128. So expanding the brackets, we get 24x minus x squared equals 128. Now to solve the quadratic, we need to have one side equal to 0. So, because we don't really like dealing with negatives here, why don't I add x squared to both sides? Because if I add x squared to this side, it'll go away. What you do to one side, you must do to the other. So I've got 24x equals 128 plus x squared. Now to get one side equal to 0, I'm going to subtract 24x from both sides. This is now the quadratic I solve. I want one side to equal 0. Now I can solve it. So the two numbers that multiply to 128 and add to negative 24 turn out to be negative 16 and negative 8. So I get here, if that equals 0, either the first bracket equals 0 or the second bracket equals 0. X equals 8 and 16. The dimensions are 8 and 16. It doesn't matter which you call the width and which you call the length. So one of them is going to be 8 centimeters, the other 16 centimeters, and we're done. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.